Hello pre-calc friends again. Welcome to section 6.6. Now this is the last section of the whole chapter, that dreaded chapter 6, right? So you made it. Congratulations. Just going back for a second, if you remember the beginning of chapter 6, we started with 6.1, which was kind of tough if I draw a little graph of how difficult this chapter has been. And then we got to 6.2, and 6.2 was okay. It dropped down a little bit. And then we skipped 6.3 and we skipped 6.4, which was kind of nice. And it's actually a good thing because 6.3 was actually a bit tougher. 6.4 we never do just because it's really difficult. And then we just finished 6.5, the inverse trig, which hopefully wasn't too bad, so hopefully the difficulty went down a little bit. But then we end with 6.6, and 6.6 brings the difficulty up just a bit, not the highest, but it's definitely a challenge. And there's two reasons really why. First of all, it brings back pretty much everything we did in this entire chapter. So you'll see a lot of stuff from previous sections in chapter 6 here. So it's a great accumulation, but it's a big part of the chapter too. The other thing that's also kind of tough is, in this chapter what we're going to do is we're going to be solving trig equations, which is kind of cool. It's actually very useful in real life, but the problem is there's just so many different types that we're going to see, so many different examples. So it's going to be hard just keeping them straight and remembering what exactly to do when you see each type. So we'll practice that a lot and you guys will be good to go. But one of the best things I think could help was a special type of notes that if we were in class, I was going to hand this out to you. So you can either download this on RadarNet or you can just make this in your own notes. Let me show you what I mean. If you see this set of notes that I put on RadarNet for you, I developed these kind of blank notes a couple years ago and they worked really well. And what it does, if you scroll down, after a little bit of open space just to make any kind of notes that you want right here is fine. When you start scrolling down, to help you keep track of all the different types that we see in here in 6.6, I have everything pretty much split right in half. So feel free to either just do this in your notes yourself, or you can print out this page that I put on RadarNet for you and use it that way. But as you go through each set of examples, you'll write down the problem and you'll solve it and solve it and solve it. But what's really best is over here on this side. This is where you can really use words or fill in any kind of phrases about what did you do for that one in particular that's going to be different than maybe ones in the future. So you can really keep track of when you see this kind of example versus that kind of example, you know exactly what to do. So this idea of hints or tricks or tips or strategies that you can put on the right hand side in your own notes or on this page is really useful. Okay, so I would really suggest as you work through section 6.6, you configure your notes this way and it'll work really well. Okay, let's get back to our regular notes. All right, so let me make a fresh page here for you guys. All right, folks, so I posted this page on RadarNet for you so you can follow along with the actual examples. So as I'm going through these, you'll have the examples, but you can be taking these on your notes that you saw before. So again, the greatest thing to do is just put the examples on one side, and then you can put all the tricks and steps and everything that's helpful hints on the right-hand side. Okay, so our goal here is we want to try to solve trig equations, which again has really useful applications in real life that we'll see a little bit later, but we're going to start with the simple ones. Because if you've already scrolled through these notes, you can see there's a lot of examples and it gets really complicated, so let's start with the basic ones. All right, instructions here. Let's solve for theta, solve the angle, and notice what we're in. What mode are we in here? Yep, we're in degree mode, and this is without a calculator, so you just got to use your brain. No calculators yet. We'll use them later, but for now, without a calculator, you can feel free to use your unit circle if you like, so if you have that out nearby, that'd be really helpful. But go ahead and get your unit circle for help, and that's totally fine. All right, question number 1, friends, is asking the cosine of theta equals 1/2. Well, where does that happen? Where angle is cosine equal to 1/2? And you can use your unit circle to help you out. But I have some useful steps here. Here's what I do. The first step is I find the inverse. Let's get theta by itself by taking the inverse of cosine on both sides. I'll get one solution out, and then there's got to be usually one other angle somewhere else where the cosine equals 1/2. Here's what I mean. If I just take number 1, and let's take the inverse cos of both sides. So I get theta on the left equals the cosine inverse of 1/2. All right, well, this takes me back to section 6.5, and I think where is the cosine equal to 1/2? Remember, cosine inverse is in quadrants 1 and 2, so where is the cosine equal to 1/2? And I think, oh yes, of course, it's in 60 degrees. Hopefully you see that on your unit circle. Good, okay, I got one answer. But then after I find that one answer, you look where else on your unit circle is the cosine also equal to 1/2. And the cosine equals 1/2 is a positive number. So you think, what other quadrant is cosine positive? I think, okay, cosine is positive in the first quadrant. Not here, not here. Oh yeah, down here in the fourth quadrant. So if you look down in the unit circle in the fourth quadrant, where is cos, the x value, equal to 1/2? And it's going to be the same type of reference angle. It's still the same 60. It's just down here. But you can't call it 60 because it's down here in the fourth quadrant. You think from 0, what is that angle right there? Did you figure it out? If you said it was 300 degrees, you got it. So the final answer for number 1, 60 degrees and 300 degrees. So again, just to review your steps. First thing I did is I took the inverse and I got one answer out. There's my one solution. And then I got away from the inverse. You step away from your inverse for a second and just look at your unit circle and think, where else? What other quadrant? What other angle is cosine equal to 1/2? And you find your other answer. And that's number 1. If you want to try number 2 on your own, go ahead and pause the video right now, and I'll give you the answer in just a second. All right, here's question number 2. Question number 2, we want to find what is the sine of theta equals negative root 2 over 2. What is theta? All right, I'll do the same steps, folks. Let's take the inverse. Theta on the left side equals the sine inverse of negative root 2 over 2. From section 6.5, I think, yep, where is sine equal to negative root 2 over 2? That's got to be, let's see, sine was in the first and fourth quadrant for the inverse, right? So that's got to be in the fourth quadrant because it's a negative number. And we think, okay, let me draw this here so I remember. It's root 2 over 2. That's a 45-degree angle, right? So it's right there. But remember we said the other time, we said that we can't call it this angle here. We can't call it 7 pi over 4 because we're going through these illegal quadrants where sine inverse doesn't live. So the only way to call this angle is to go this way, a negative. So the first answer should actually be negative 45 degrees. Ooh, okay, that's great. Here's your problem. Ready? Here's where I might get you a little confused. I can't call it negative 45. But Mr. Brown, you just told me you have to call it that. Yes, you're absolutely right. But can I take you back to the instructions for a second? Do you see this part here? If you think about it, my answer has to be between 0 and 360. Does that mean I can get any negative angles out? Is that possible to have negative thetas here? No, unfortunately not. So if you said that the answer is actually 7 pi over 4 or 315 degrees, that's actually the better answer here. That's actually kind of confusing because in section 6.5, I told you it had to be negative 45. But now in section 6.6, the instructions say in one circle, no negative answers. So the first answer is really, really that angle. Okay, good. First step is done. But now we got to think where else is where else is sine negative root 2 over 2? We got quadrant 4 over here. Good. Where else is sine or y value negative? And I think right over here in the third quadrant. Same angle, right over here. What would that be? If I go from 0 to that angle, how much would that be? Think about it for a sec. Did you get 225 degrees? Me too. The great thing about these kind of questions is you're solving equations. And remember, from all your years doing math in high school, you can always check your answers by taking your answers and plugging them back into the original. For example, if you say, what is the sine of 315 degrees? Yeah, it is negative root 2 over 2. Your answer is right. What is the sine of 225? Oh yeah, it is negative root 2 over 2. So you can always plug these back in and check your answers. All right, those are the basics, the basic kind of problems. When you move forward and you try the next on your own, you can use the videos to help you out, check your answers, but try not to. If you don't have to, try to do it on your own. Just notice on number 3 and 4, nothing's much different except the instructions. Now what mode are you in? Okay, still no calculator, but now you're in radian mode. Once you get into 5 through 8 over here, notice what the instructions say. Degree mode. But does it say without a calculator? No. So definitely, look at these decimals, you're definitely going to use a calculator. Okay. Use the tips and tricks that I give you on those worksheets that come with it. But if you have any questions or problems, check out my other videos and I'll help you out. Good luck, folks.